Morning, friends. It's my pleasure to take you the small journey. It's like more like an introduction to a big field because the automotive vehicle in which you see its history, it has been going on for last almost 50 years. There are some beautiful papers from Ford, Toyota, Honda, right from 1980 or something. Today also you will find those papers relevant. It's not that there is old technology. There are some findings, whatever the achievements they made, discoveries they made, they are still valid after 30, 40, 50 years. That means you can see the growth is tremendous. What happened actually, I will tell you. Many of you may be knowing the story of NVH. It actually came from durability. When Ford started making vehicles, initially it was very good, appreciated because they replaced the horse carts. People used to go by horses, horse ride, and then they got very good automatic vehicle. But there were a lot of failures in the chassis to break because engines were directly bolted on the chassis. There was no such concept of rubber mount, isolation, vibration isolation. Silencers were used to be very rough. Just a tremendous noise should be there. But people are not bothered because they didn't want to travel. First time, people used to travel by steam engines, in comparison, steam engines, vehicles were much quieter. But then slowly, because of durability issue, they introduced rubber isolators. Then they observed there is a lot of vibration isolation. And because of that structure bound noise also coming down, and vehicle is becoming quiet. And then the entire journey started. You developed dampers, you developed absorption measures, and then you have got hydra mounts, you have got active noise cancellation, electric vehicles, hydrogen fuel cells, and now everywhere you'll find that NVH, noise vibration harshness, has become a DNA. It's not previously, maybe at 10, 20 years back when I started my journey, at that time NVH was more like a luxury. If you want to have a premium vehicle, let the NVH be considered in the design part. But we are selling simple vehicles. We are just, especially in Indian context, we are not selling very high costly vehicles. People used to somewhat remain away from that. And today that trend is also in commercial vehicles, especially in trucks and tractors and pickups and rickshaws. Still that trend is there. But still you'll find that whatever the trucks we were making in 30 years back and now what we are making, still NVH is much improved. Whatever the rickshaw was there, you remember your old good as childhood days. What rickshaw was used to be there, now on today rickshaw is there. Still everywhere there's improvement, and especially in cars and passenger cars, the NVH has become just like an integral part. It's a pillar of the design. So we thought that we'll have this introduction to you. The silent revolution on road. Why vehicle NVH matters more than ever. Previously, what used to happen? Vehicles used to get sold just by the name, style. Then slowly the trend came of fuel consumption, how much mileage you get, how much power you get, and many other features. But after a certain time, they observed that there is saturation because most of the computers, you take Toyota, Honda, General Motors, Ford, all of them are competing, Enroll, they're competing with all these parameters. And then they observed that the vehicle which is giving more comfort on the road. Not only that, beautiful design of the sound. It's not that people just want only quieter vehicles. Now people are thinking that electric vehicles are somewhat boring because they don't give me thrill of driving, especially on long drive. In cities, okay, we want quiet drive. But when you are driving from say Mumbai to say Delhi, like an example, Samruddhi Express, and we have got that, and hours you are spending, and the vehicle is so quiet, and people are somewhat finding it boring. And then people want now sound design to be made. And now there's a possibility that, especially with the autonomous vehicles, people have different vehicle. An autonomous vehicle is like an office or home rolling on the road, and people want to be very much relaxed, and they want music, something it sounds to me something different, unique to their personal preferences. So the field is advancing like anything. So we'll be just covering such topics like why environmental noise pollution is there, what are the customer demands in a brief way, because we have got a only 1 hour session, and we'll be also taking some questions answer on the inline or offline. And then we have got full complete courses for who is interested in that. So What are the conflict of NVH requirements when you are developing NVH? What other problems can come? You have got compound design, then you have got different strategies for structure-bound, airborne noise, need of transparencies. You have got AI, ML, artificial intelligence, and machine learning applications also in NVH. Are there here? Yes. Optimization tools designed for Six Sigma. New law regulations by CMVR, that is Central Motor Vehicle Regulations. These regulations are coming in India and already they are in European countries. And you'll get wonderstruck what are the challenges in front of us. Electric vehicles also. There are special challenges. People say it's quiet. But are they really silent? We'll discuss. And autonomous vehicles and future energy points are there. Now, please remember that these topics themselves are very vast. And I will tell you literally hundreds of researchers from different parts of the country, different part of the world. They're working on all of them. So I'm just going to give them just glimpses of them so that you will understand. Oh, this is the topic. This is the complexity. This is the wideness. So that is the only purpose. And those who are interested in knowing more on this in particular topic, they're always welcome to contact me later. Okay. Thank you. So my background is I'm just covered here. I did my MTech and PhD from IIT Bombay. I'm mechanical engineer, and 15 years experience I got as an image manager. By God's grace, I did completed PhD in the same field, and I work in the same field. Sometimes it happens that you are working in the you're done PhD and MTech in some other field, but your career is different. But I'm fortunate to have almost 34 years of career only in the same field, that is noise vibration harshness, where I did my PhD and MTech also. So we'll go ahead, we'll take a small journey, friends. So what is design? First thing, noise or the sound. First, forget about noise. The sound is our friend. Please remember, believe it or not. Notification is important. Aircraft is going on. I'm aware of that. Suppose our enemy country. Suppose they sends aeroplanes on our city to bomb blast. You should be aware now. Array, some sound is coming. Run. Okay, so notification is very important. So don't really say that the sound is I want to kill the sound. No. Sound is our friend. Okay. Second thing, it's a pleasure also. Yeah. Without that, can we live without music? At the same time, friends, it's a disturbance. There are many times, especially a school. The teacher is teaching the students or colleges, in the seminar is going on, and in a hospital, ICU there, in ICU, patients are there, and you are nearby this on the road. Many vehicles are running. The tire road noise, engine noise, a lot of noises are coming. It's a really disturbance, and then that becomes harshness, noise. Oh no, I don't want that. It's really noisy. And sometimes I tell you, long back, we had sent some vehicles from Tata Motors to South Africa 15 years back. And the dealers said, we can't sell these vehicles. Why? What happened? Oh, when we are driving the vehicles, we are not able to talk to each other in the vehicle. Actually, well, we had checked these vehicles at our end, and we said, how come? And then we observed that in South Africa, because the roads are so high, so beautiful, average speed is 140 to 150 kilometers per hour. And at that time, we had got the problem of wind noise. We had assured that up to 100 kilometers, the wind noise is not there. What happens at very high speeds, because the aerodynamic forces, the wind increase happens, and the air rushes inside, small forces. So ceiling has to be very perfect. And if the ceiling is not perfect, so we had made the ceiling perfect up to 120 kilometers per hour by our Indian road driving condition. When these vehicles reached South Africa, these people used to drive at 160, 180 kilometers per hour. And then in the vehicle inside, it's only noise. You can't say turn right. So you cannot talk to each other. The articulation is the same. Very poor. So that is what when the noise comes, then we have to work on the redesign of the road seals perfectly, to work on all other aspects of body leakage and all the things. And then the vehicles were then sold afterwards with these corrections. So point is that what is desired? Then this is noise is not at all desired. Music, yes. Notification, yes. But this is not desired, and that is why we have to continuously work on that. Now somebody will say, electric vehicles are very quiet, very quiet. Yes, Definitely, they are very quiet as in comparison with diesel engine vehicle and petrol vehicle. Very quiet, very nice, especially cars. I'm not talking about electric buses where there are a lot of cooling fans are there, but electric cars, very quiet. They are when they pass by very quietly. They have got different problems inside the vehicle that we'll discuss after later. But they're quiet. But what is the situation? Do you know it? There is a situation called we have got acoustic vehicle alert system. That means especially at, up to 20 kilometers per hour, they are so quiet that people don't understand. Are military vehicle is passing by. So especially for the old people, the blind people, and the children, it's very dangerous. So there is a regulation in Europe, in India, it's yet to come. There you have to provide acoustic vehicle alert system. That when we feel 20 kilometers per hour, there will be a small speaker in the motor compartment. It will create a sound. There's a limit on it should be more than 56 dBm at 2 meter. So this when passing by, it should create sound. Now you see one electric car is going at 20 kilometers per hour and it's producing sound, will not matter much, but we do not matter much. But if many such vehicles, especially in traffic jam, they're moving, crawling, and all of them have got AVAS, okay, acoustic vehicle system. You just see how many dB will be added to each other and how much noise will be created. It will be a nuisance. So that will be also a big problem. So whenever the population of electric vehicles with AVAS will increase on the road, especially in the traffic jam area, then you will create this problem also. Now, as far as vehicle industry is concerned, we observe that 50 to 30% complaints are due to noise and vibrations. So acoustic is not a car's future in demand. If it's ignored, a serious dissatisfaction. When you are developing vehicle, nobody says, from NVH point to tell me what are the features. Nobody says like this. People generally say, what is the torque? What is the driving ability? What is the aesthetics? What is the different features? What are the other and other things? Crash safety, many things they talk, and durability, of course, everything is there. But NVH always is at the back. It is considered as like a cake on the ice cream, something. If NVH is good, good. People used to think always like that, but it's not happening. So friends, remember that those who ignore this in the during design and they say that's okay, let's launch the product. Tremendous reception there, and people simply go to the different brand your competitors. This we are observed, and NVH has to be improved in every aspect. As far as regulations are concerned, noise levels are coming down and down, and these are, I'm telling you, noise levels in India, we are yet to catch them. We are still following 74 dB only for passenger cars in India, but very heavy trucks. But in almost Europe and other countries, this is going on. Okay, so this is we are also going to face this problem. Keep pass by noise limits have to be reduced. Now, when you talk about vehicle level, you have to come down to compound level, because if suppose I want to reduce pass by on the vehicle, I have to reduce the tire road noise. But when it comes to compound level, when I'm trying to reduce noise of tire, the durability, weight grip, rolling resistance, ride comfort, apprehension, all of them come together. And that is why there could be conflicting requirements. And this is what has been observed, that quiet tires are not durable often, because if their damping is increased, stress is increased because of road friction, the heat increases, and there could be a problem. So you have to design every vehicle component to reduce their noise and vibrations, but at the same time, other performance requirements should not be affected. And this is a big challenge in front of everybody. And many times then it happens that NVH recommendations are taken aside. Don't worry, we don't want quiet tires. First, they should be durable. But the grip should be good. Rolling resistance should be reduced. And then in that case, NVH manager or NVH designer or the NVH team leader or NVH big boss has to take a big decision to create an alternate solution. If they're not accepting this, what should be another solution? And that becomes a journey. That's why this field becomes very challenging, and it leads to a lot of innovations. That's why you'll find that over the years, a lot of innovations have happened in this field. People have come up with different techniques because certain traditional solutions are not accepted because of other things. So that's what we said. Quiet are still in the maturity stage, tire wear, highly damped tires, vehicle handling stability. These are all still questions and still the research is going on. And that is why you don't have today quiet tires as such. Can you give me quiet tires? It's not still there. Some people can say that tire A is 2 decibel lower than tire B. It's not sufficient. We want much more reduction, and still research is going on in this field. Now, what are the steps already taken for by developed countries? Again, India is far behind that for human population, but confirmation of production for NVH or used vehicles noise monitoring. Already there in Germany and other things, Japan also. But a confirmation of production is there in India for only emission. They will take up pick up any production vehicle and just see at the time of launch the certificate values and these are matching or not. But afterwards, you observe in case of noise also, whether at the design stage, whether at the production stage, when we launch the vehicle, what was the noise level? After some kilometers of running, what is noise level? Is it deterioration? Noise has increased. This is checked in India, and if this noise increase, the vehicles are banned in developed countries. This will perhaps come in India also. And in that case, you can understand our NVH solutions have to be much robust. As the vehicles run over of thousands, lakhs of kilometers, the NVH load should not get deteriorated. The best vehicle in the world, which is the best vehicle in the world, which has seen generations. It's called Toyota Corolla. Toyota Corolla is a vehicle. It was launched in 1966 and it's still been going on. People say that this vehicle is boring. Boring in the sense, after 40 years also, they say that after 10 years, 20 years also, the vehicle exactly looks like the original one. That kind of Toyota quality is designed, and perhaps we will have to design in such a way every component that it will withstand all the time and road driving condition. There are two important points, as already mentioned. The public is affected by road noise, so you have to improve health and quality of life. Just people say yes, you have to work on that, on the solutions. You have to improve the big silencer. You have to create bottom shields to the powertrain. You have to give the car tires. This is what is needed by the whole public, and the government will say the same thing. On the other hand, what will happen? Friends, see, vehicle, what many commercial is thinking, all the cost, time of development, conflict with other performance, they have to bear that burden. And finally, what will happen if they added bigger silencers on motorcycles to reduce noise? They added big powertrain shields, acoustic shields below the powertrain to reduce noise. They developed a very costly but quiet tires. Finally, who is suffering? The cost of ownership. Well, the customers may not accept such costly solutions, and the vehicle managers will not have profit. So this is also a big problem. So that is why again I tell you, then we are facing with R&D, research and development challenges in NVH. What should be done from the outside the vehicle? This should be also done. Quiet roads should be there. You just see this particular research work. They observe that in passenger cars, just by changing from dense asphalt single layer road to double layer porous asphalt, there was a reduction of 10 decibel. And this is happening in European countries. The quiet roads are already there. There are trees along the side of the roads. There are sound barriers, traffic flow management, training incentives. So only vehicle reduction is not possible. And we should also have the reduction from all other aspects. The human perception of vibrations and limits of discomfort. Or the same, when you are talking about only noise, what about vibrations? The duration is inversely proportional to amplitude of vibrations. So you'll observe that the safe limit, you'll find that when the people are driving the trucks, the buses, for 10 hours journey, the vibration level of the whole surface, vibration and diversity level, single vibration should be less than 1.4 meters per square. If it's only for 10 minutes, okay. So vibration levels has to be there. So there is some standard for that. So vehicle we are designing for noise reduction, vibration components should be also seen in that direction, so that both psychoacoustically the passengers and drivers are compatible. As I mentioned already, fire and NVH level, you've got vehicle integration space, also your vehicle weight is there, durability needs are there, and in all this, there will be a lot of compromise. For example, in order to reduce noise, I will say that I want 20 mm thickness foam on the dashing or the firewall, but and another 10 mm thickness of the covering layer, like say barrier. The vehicle manager will say, "Ki, "Arey, but I do have got very little space between the firewall and the engine, or I got very compact space on the dash inner. I got already there, levers are there, clutch lever, brake lever, everything is there. I got limited space." Then your solution becomes down because the thicker the acoustic insulation on the body trims, lower will be noise. So vehicle weight is important. So all such things you have to take into consideration. And that is why I'm telling you, ki, on one hand, customer demands are increasing. Previously, they used to be work on the wind noise, but now transmission noise was there, cooling fan noise was there to be. They are complaining. They want door slam noise, even how the door is closing is good. Overall, sometimes noise is good, but sometimes they find it in the rough. So you will find that demands are increasing amongst customers, and customer will keep on thinking that I want a brand sound also. I want sound which is as per my liking. So on that side, you can understand how much efforts you have to take while designing the vehicle. Now, from that point of view, every vehicle component influencing innovation should be critical. Take an example, engine. You have got cylinder block, piston, a big list. Exhaust system, muffler, exhaust hangers. Then you have got driveline, gearbox, propellant shaft. All of them will find everywhere you have to work. Every component, if is meeting the target of noise vibrations levels, this should be a particular level target. This particular silencer, it has got some transmission loss. Okay, sound comes inside, times goes out. What is the difference between the D? Sound pressure coming inside, in and out. The difference should be minimum 30 decibel across the whole active band of frequency from say 200 to 600 hertz. Is it meeting the target? And even unless it meets the target, you cannot sign it off. In this way, we have to work hard. And in case of hybrid electric vehicles, when it is both in series or parallel, you are charging the engine, charging the motor of your battery also engine, or whenever the motor is not taking the load, you are bringing the engine. You'll find that the challenges are much more. Everywhere you have to work on that. If suddenly sudden torque change reverse happens, then should I put a headlamp on there? Should I put a Rosner vibration damper in the driveline? You have to work on every aspect. And this is a famous V diagram. You have got one vehicle level target. You start from um, your left hand top corner, and then you have got basic target. Okay, I want to meet the target. Passban is 70 dB. Is measured at only 7.5 meter on a road. So what are the subsystem targets? Basically, I observed that silencer is creating big noise and near tailpipe noise. When I go very close to the silencer, the tailpipe, there is a should be 90 dB at the maximum speed at 0.5 meter. We are going pretty close. Away from that, the sound comes down. Now, once I come to know, I have to design the silencer in such a way that it meets the basic requirement, insertion loss over this particular frequency range. Then I have to validate to see component engineering. Different tools are there like GT Power or ANSYS Fluent or many Ricardo Wave. There's many software are there, or you have got your own experience. You have got design rules, and you develop along with the component supplier different silencer, redesign it, check it. The transmission loss is greater than 20 decibel. Then again validate the whole vehicle. Again go to the final vehicle, and then you solve this. So this is how performance cascading to happen on every component and subsystems in the vehicle. Then only the vehicle will be meeting the targets of NVH. People generally say that key acoustic simultaneous only, but the vibrations is more important. Okay, you just tell you what is noise. Basic definitions: airborne vibrations is equal to noise. In air, I am talking to you. The air particles are vibrating in between you and me, your laptop or your mobile phone, and the air. They are vibrating and they're sending the sound waves. So vibrations initially at low frequency affect human comfort, but at higher frequencies, the amplitude becomes smaller and they generate sound. It's called structure bound sound, and it decides its sound quality. Then it adds vehicle noise. So whenever you're controlling vibrations, automatically acoustics also under control. Only at very low frequencies, if the noise vibrations are controlled, the sound waves will not get affected much, because at very low frequencies, the sound waves are very long and they are not very harsh to human frequency. That will see when you say dB level and all that. When you go to the basics of this topic, you will come to know that mid and high frequency vibrations are only important for noise. So when you see the vibrations, there's a famous story. There was a Tacoma Narrow Bridge in America, and in 1942, just after inauguration, it just collapsed. What happened? The natural frequency of the bridge structure just matched with the one of the excitation frequency of the wind forces, and the working stresses were so amplified because of resonance. The whole structure got collapsed. So this is the important. Now, such type of things will not happen in our automotive image. But the point is that resonance has to be avoided in all aspects. The resonance may not cause a failure, but they will each and every component of the excitation. Maybe for engine, you have got road. All the excitations will create some particular frequency component. For example, at 900 RPM, you are just seeing on this. If it's a single cylinder engine, you'll observe that first firing order itself is 15 hertz. And if that this particular frequency is excitation frequency, okay, and through FFT analysis, we are seeing the different components of the frequency components. And if this particular excitation frequency matches with the natural frequency of any component, for example, engine mounting system is there, engine with rubber mounts. Engine is a huge mass and it's got rubber mounts. That itself has a bouncing frequency, big mass jumping up and down on the mounts. And if that is most close to 15 hertz, you can understand that entire structure in that entire engine is getting resonance with this mount system, and the whole body is shaking. I actually have seen my life many times. The whole vehicle is shaking like anything. You cannot sit inside, especially idling, and you have to then decouple that actual frequency. And that is why in this way there could be various such order trackings. Various at different RPMs, you have got different frequencies depending on the harmonics. You have got frequency proportional speed of the rotating component. And especially for electric vehicles, it becomes a very big problem, because you have got first order maybe on the motor imbalance, but then you have got 8th order, 20th order, 40th order, and 60th order. They come from transmission, number of teeth, and you have got sorry, you have got first order, 8th order, and many such uh, orders are there. And then you will find that electromagnetic orders and gear machine orders, they are coming all the way. And motor RPMs go up to even 9,000 RPM also for high torque. And then you cannot avoid the resonances. So auto tracking is one of the best tools for electric motors, alternators, cooling fans, bearings, engine firing, tire wheels, brakes. So such advanced tools you have to use, go to root cause analysis. And then for that purpose, we have got a lot of such software available for data processing, like time domain analysis, frequency analysis, and various organizations are there. I'm just named a few of them. They're very famous for last many decades. We have got time domain analysis, frequency analysis, mode analysis, running mode analysis. You have to, these are all specialized tools so that you can actually diagnose the problem very well, and you can go to the root cause. Now it's 11:30. Do we need any break for this, or should we continue? If you don't need break, I can continue. Otherwise, we can take a break of 5 minutes. Or shall we go ahead? Okay. Am I audible, friends? Anybody can unmute and tell, or Saurabh?
Sir, please continue, sir.
Hello. Shall I continue?
Yes, sir. Continue.
Yes, sir, continue.
You don't need break time because it's a small session, so we'll go ahead. Okay. Yeah. So transformer analysis, these are all specialized tools, because vehicle is a very complex system. When I'm driving a vehicle and somebody says, "Arey, I'm getting a noise, very high noise coming from outside, and I'm feeling some kind of boom is there," what is responsible? Which component is responsible? Whether the roof is vibrating, whether the floor is vibrating, or whether the driveline is a problem, or whether the engine is getting a problem, or engine mounts are responsible, or any particular structural component is responsible. For that purpose, all such tools are required. And this is equivalent tools are also available in digital domain. These are in physical taste domain, and whereas you have got similar tools available in CA also. Now, most important point that whenever you are designing all this, all the solutions should pass durability testing on the components on roads, because if any solution, maybe in terms of vibration control or sound absorption reduction, if they don't meet the durability requirements on especially on Indian roads, you can understand they'll just throw away for emission, in which will become very bad. So how to match the durability also and image, this has to also be sustained. And that is why we come to know we have got vibration based condition monitoring. Initially the vehicle is good, components are very good. After some time you observe that after certain running condition, operation condition, you find that array, there is something has gone ahead, and sometimes there is catastrophic failure. Before it should happen, we should monitor their vibrations and noise levels and see that all the levels are at par with the set targets. So for that purpose, vibration-based condition monitoring is required. And then it was failure then can be well monitored. For example, for a bearing, when you see the failure starts, it may not be detectable at that moment, but vibration levels go up, targets are crossed. Again, people may not find it something is normal. Targets are crossed, again structure on oil also. Then slowly people say the oil is contaminated, heater is there, and then there is an audible noise. Now before you take the action, perhaps there is a failure also. So you just imagine right at the beginning, suppose if you have got when the targets are getting crossed, at this stage itself, if I take the vibration levels, if I take the noise and I see that, monitor them, then this will not be there at all, right now. And this has happened, especially in Russia. It was recorded in 1976. There was a gas turbine going on, and vibration levels on a higher side. But at that time, people said yes, vibrations are higher side. The maintenance managers to say that vibration levels are increased, and they said, okay, yes, but this is huge structure, huge system, and it was generating power. And at that time, one evening, there was a party, some send off was going on for some prize, and at that moment, the rotor broke away because of continuous vibrations. Bearings also gone away, but they didn't realize at one stage it got collapsed and the entire building got totally destroyed, and 60 people died. So condition monitoring for vibrations is very important in automotive image also. These things are coming up. So when it comes to sound quality, there's a lot of frequency range. And when you say that this noise is very good, this is really painful. I'm not able to even hear you, man. It is very so quiet. You are talking so low. In that case, there is a particular amplitude and frequency range. You have to make the balance of that, and you have to go further behind that. There's a big field of sound quality research, and those who are interested, they can come visit this. On the other hand, you have got to see that key, just as we observe for vibration monitoring, for health and noise for exposure also from World Health Organization, we observe that key, beyond certain limit, suppose for 8 hours you are continuously exposed to 85 dB, the issues like hearing, physiological sleeping disorder will happen. And sometimes they observe in Europe, they have made good studies, and sometimes heart patients also suffer a lot because of exposure to excessive noise. Okay, and when the duration reduces, you see even for 100 decibel at 15 minutes or 127 decibel at even for 1 second, it's not allowed. It's a huge noise. Not only your your drums will break away, you will have problem, but it will affect your health also in drastic sense. So this is what the World Health Organization talks about that, and this is very useful, especially in aircraft industry and other things. Very much importance. Now we come to a small topic. What is harshness? People generally say, what is noise vibration? I can understand. Noise is measured in sound pressure level, dB level. We have got vibration levels. We have got meter per second square. And what is harshness? So harshness represents the subjective sensation of the human body towards vibrations. So this is what. So what happens? So what happens? You have got that key. You have got air outlet and turbine wheel. You can see suction is there. Okay. So a tonal sound of turbo whistle. Okay. Ooh, or even can electric vehicle also. There is a ooh. You will find that sound pressure level per se, dB level, is on the lower side. Vibrations, if you really measure, they are on the lower side, but they are very harsh because it's a one particular compound tonal sound. Ooh, it's disturbing. On the other hand, people find that a racing car, it's a powerful racing car. Nobody complains about it. In fact, they like that roaring sound. People really fall in love with such sound. The same thing is with these things. Example like old diesel truck versus a musical program. If you see the noise levels, they're not very much different. dB level, if you see it is 82 dB there, and here also you made this maybe 90 dB also. But the kind of music that got melody and that atmosphere is phenomenal and it's something different. So harshness is not related to dB level of noise or meter per second square or G level of vibrations. It is a psychoacoustic response. And that is why a lot of research goes on that. And that is why it's a separate science. It's a psychoacoustic science. Noise vibration harshness is something different. You can keep the high level of noise also, but it can tune its frequencies and amplitude in such a way that you will find it enjoyable. On the other hand, the vehicles, like I told you, electric vehicles, they are very quiet in general. But some fan noise starts, humming sound is there, and some or inverter buzz is there. Inverter is creating sound, buzz sound. It's irritating, like a mosquito. They say mosquito effect. A mosquito comes very close to your ear, and it's so harsh. If you take the microphone and measure noise, very very low. But how can I explain harshness? So that's why this is a separate field of harshness, and a lot of research is going on, and we'll be covering the complete course. What is it? Now we'll just talk about some detailed aspect like what is structure-bound noise. Structure of panels vibrate. They sit surrounding air particles in motion and sound wave propagation. Entire panel, roof panel, bonnet vibrates, and you get a structure-bound noise. On the other hand, airborne noise is only through airs, and the fan noise there. It happens only in the medium. Okay, airflow is noise there. Okay. So a vehicle has got both sources of noise in a vehicle. Okay. You got airborne noise due to sound traveling inside the cabin through gaps, doors, sills, and firewall gamuts. On the other hand, you got stored structure-bound noise due to body vibrations excited by powertrain, rotor vibrations, so engine mounts and vehicle suspension bushes. So you have to take care of both of them. And then we observe that it's generally trained in the frequency band. 80% is in the low frequency zone. Okay, and 20% in 500 to 8 kilohertz, and vice versa. In airborne noise is 20% in low frequency zone, whereas generally, which is a typical example, it's not will happen about every vehicle, and 500 to 8 kilohertz is for airborne noise. What is the ideal way of installation of power units? For every element is needed vibration isolation, damping, acoustic enclosure, sound absorption, perfect sealing. And when you do all these things, then only the entire noise will come down. Both structure-bound and airborne noise control. And the same principle we use in vehicles. If you go to especially multinational company generators and all that, you will not understand that a big turbine is running inside. So quiet. They take care of every aspect of vibration isolation, damping, acoustic enclosure, sound absorption, sealing. And that is the aim of, there is the same principle used in automobiles. And that is why you have got like this, various measures, additive vibration isolation. We have a lot of such practical case studies, and you can see that. And so many papers are there how Ford has developed, how Jaguar has developed the solutions of very different vehicles using all these techniques. To control measures, you have got airborne noise, body sealing, acoustic insulation, avoid the turbulence also in the path, on the flow, and minimize acoustic power. So, as a part of that structure-bound noise, you have got modal analysis. How modal analysis works, how you get the natural frequencies, mode shifts, and damping. Now, every component has to go through that, either through experimental purpose or you have got equivalent CA tools also for that. For CA tools also we'll discuss later in the complete course. That we have got a full total final analysis, boundary element analysis, you have got fluid index noise analysis, and we have to cover through them. And then finally you get either through CAO test, deformation shapes, either through FEM or either through experimental model analysis, get the deformation shapes, find out what are the nature frequencies, whether they'll be really creating a problem with the excitations that you are getting in your vehicle. And typically you see that structure either through FEM or experiments. What are the nature frequencies? Are they coming closer? For example, 3389 Hertz. Generally, it is very close to the brake field frequency. When you apply brake slightly, when you're approaching a road, when approaching a bus stop or something, especially buses, when they approach a bus stop, they apply brake slightly. And at that moment, it's a Sticksley phenomenon. And at that time, that impulse, small short time interval impulse can excite the whole brake drum or disc or the brake pad, and they get set into resonance. So this is around 3 kilohertz, 3000 hertz it happens. So you have to check the components, whether that frequency can be shifted here and there. The decoupling can happen. The rotary, on one hand, you got a rotor disc or drum is there. On the other hand, you have got brake pad. Can you decouple their natural frequencies? So that is why modal analysis is very important, both from test and CA point of view. And once you get the different mode shapes, you have to see the significance. One particular mode will be there. It will be definitely just directly coinciding with the excitation frequency. But if the excitation frequency is not there, excitation forces are not in that mode to excite that mode, then you can simply ignore that. So that is why you can do optimization also of the structure. Otherwise, every structure will become very heavy and very stiff and tough, but the cost of the and weight of the vehicle will go up like anything. Then you observe that engine structure modes of vibrations are many, and you observe that uh, you observe that for different components, you have a different frequency range. Like for cylinder block, crankcase, in this is a very high frequency zone. With bed plate, you can reduce it, but not much level. And that is why you have to take both stress model plus CA model and work together and see that you get the fast solution to correlate the whole modal response of the whole structural component, the powertrain, and the vehicle body chassis, and the final noise level at the driver layer or passenger level. And for that purpose, different tools have been used both in CA domain, where I mentioned about different FEA software are there, model analysis there, you do transient analysis, mode analysis, or harmonic analysis. And that leads to transfer analysis. You have got a sound pressure level at the inside the cabin, and it's composed of various sources. Then how you define transfer functions from the engine mount point. So the persistent input point is that transformation called NTF, noise transfer function, and there's a Osher transfer function for the radiator sound. So how you control them? There will be many such sources will be there, many such transfer paths will be there. You combine them, and total mean square sound pressure level with summation from all uncoded sources will be given to you. And in that case, you can see the contribution of each source. And then a typical example will be like this. It's an example. So sound pressure level from 8th order of electromagnetic wave. Because military vehicles you also do this. There is a particular high-end is there, and it is say at say 5,000 RPM, 50 decibel. It's the 8th order of electromagnetic wave because the number of poles the motor is 8. So you have got 5,000 RPM and 8th order, and it's 50 decibel. And you will see that from where my maximum is coming, and you'll find that there is a contribution from the gearbox mount. Around 35% is coming from there, and other things airborne and other things. So in this way, you have to do transfer analysis. Then only you will find out the root cause from where the noise is coming. Then I just go to the gearbox mount. I work there either on the rubber mount, or I will have to find out whether supporting bracket itself, which is carrying the mount itself, is going to resonance. I have to work on that and then give the solution to the management, and then the problem will be solved and the vehicle can be launched in production. Otherwise, you'll find that near 5,000 RPM when the vehicle comes, there's a that noise will come and then say, overall the vehicle is so quiet, but what I'm observing this, and you have to eliminate that boom and to kill that resonance. You have to work in that direction. For that purpose, transfer analysis is required. And then you have got optimal stiffness. There are some lot of technical papers are there. We'll be considering that, and we observe that there's a found an optimal value of the body stiffness, or which the road noise comes down. So observe that when the BRW stiffness was one particular level, say 1.5x, the initial stiffness was x and 1.5 stiffness was there, then only 2 decibel noise came down. So this is how the stiffness of the body and the final level of interior noise, they are correlated to each other. And as I mentioned, a lot of people work in the direction. Final solution, when you see a particular vehicle comes and you see that it's so quiet, absolutely free from boom and anything, then you may understand that hundreds of engineers have already worked on it. It's designed in a very scientific way. And that is why we come to the target cascading for the vehicle to subsystem to component. If you don't want any boom inside the vehicle, you have to maintain the linearity of the sound pressure level. And that is why you have to come down to subsystem level. And then you see you have got trim body component level. I may have to go for smart faster because of lack of time. So there are international targets are there. The noise transformation should be lower than 54 dB. Noise transformation should be less than 1 mm per second per Newton. And a lot of theories there how these targets were derived. Overall, if you see the frequency range, right from 0.1 to 1 hertz to say 1010 kilohertz, you'll find that different excitations are there, different subsystems are there, different design attributes are there. It's a huge field. It will take some time to understand. So I'm just want to give you a glimpse of this, how much complex the entire system is there. Because you may achieve noise NVH refinement at one particular condition. Like I said, idling is very good, at low speed is very good, but in the mid speed, somewhat rough, and at high speeds, there are some different problems are there. So you have to work on each and every aspect for every component subsystem in all different frequency ranges. And for accordingly, the tools are so different. In case of field level, tools are different. In case of CE domain, you have got final analysis for up to 500 Hz, then body element analysis for about 600 Hz. Then after that, you have got statistical analysis tools are there. Then for fluid analysis, some other tools are required. Some noise analysis, you need some software like hyperelasticity or exhaust flow noise or compression fluid dynamics or wave. So tools are also different. They differ according to frequency ranges. You have vibration isolation, isolators, engine mounts, body mounts, suspension bushes. It's a big industry for that. Different tools are there. How to design the vibration isolators for killing the vibrations and reducing the destruction of noise. Here, the frame and chassis will play a big role in considering the final vibration level along with the isolators. And there are some tools like dynamic absorbers. They are used not only for big buildings, but in the dynamic absorbers are very famous in automotive industries also, because they make use of system damping. How beautifully they control the resonances is a big theory. And that is why we see that NVH manages from project execution, project specification, execution, and production. At every stage, you have to work from benchmarking to the customer satisfaction. And in between, you have got simulation as well as proto validation also. And that is why you have to work on all these components from powertrain side and from the chassis side. And then we observe that cost effective analysis is done. This is a paper. I have written many such papers. I am the co-author and author of many such papers. And then we observe that cost effective acceptable solutions can be possible if you work very hard. Like if you work on only body mounts, materialization, suspension bushes, and PVD, you can replace a costly solution like dual mass flywheel. So we have to work on all such directions. There's a multi-direction option optimization needed. For example, you have got a durability, NVH, vehicle handling. I told you the final engine mount design is a combination of that, and optimization algorithms also available across the world, and different software are available like front module transfer. Various optimization algorithms also available for carrying out that, and it's a part of our design solutions. We have got acoustic treatments on a trim body. We have got incident sound, reflected sound, and a lot of absorb sound. So how you design the whole theory? On one hand, you have to absorb the sound as a barrier. You shouldn't allow it to go ahead, and some sound should be absorbed inside a frequency band. And there are some techniques also there. Like for example, sound absorption will be measured. You have to develop new novel tools, novel materials in such a way that the sound is well absorbed and nothing comes from the either from the road or the engine or the motor compartment inside the vehicle. What are the different challenges at the end we'll see? Don't make only one car quiet, but millions of cars to be made equally quiet. So design for Six Sigma is very important. This you know this all vehicles should give equally same level. So you must see that all vehicles should be same. So tomorrow if I take a vehicle, I'm very happy. But if tomorrow my brother takes a vehicle and he's not happy for the same design, is it good? Not all good. So there's a separate tool for that, how to design for Six Sigma. And it is very much useful in NVH, DFSs, design for Six Sigma NVH systems. And for that purpose, then extremely low variability we achieve with the Six Sigma quality. Second challenge is, I mentioned about artificial intelligence and machine learning applications. This is really required for transformer tools, especially for pattern recognition. So we can improve the efficiency, accuracy of the all the data that we collect. For example, tomorrow, which sound is really required by the customers? What kind of sound, especially ladies, what kind of sound they like, and young men, what they like, and the senior citizens, what they like. You can collect all this data, and accordingly, the frequencies, dB amplitudes are adjusted in such a way that you can give the particular vehicle as per the requirement. Senior citizen couple comes, they will have a separate sound, and the vehicle is designed from that. Thanks to AML, and they will help in this direction. So ML algorithms can analyze driver behavior, sort of import braking patterns in relation to NVH levels, and then they will have a they can solve large scale optimization problems. Then onward noise pollution already we discussed. The new method is coming as a separate tool. So in a short period, I cannot explain all this, but a traditional method is there, and now it is getting changed. A lot of changes is happening in the EC economy, Council of European. So they are changing the regulations, noise regulations, and so Economic Commission of European, they were totally changing the test procedure, and they are also changing the noise limits, so you can understand what kind of targets you are going to. Today, if the noise level is 77 dB for motorcycles, it's going to come down to 70 dB. And remember, you have to be very much careful about this. Okay. So the traditional, what are the solutions are there? Like acoustic shielding, bigger silencers, or ground gears, discus fans. They may not be sufficient. You have to develop some new tools. For example, intelligent management of vehicles, high damping materials, active control of exhaust silencers. All this will be required. Electric vehicle challenges already were discussed, but again, let me revisit. Key electric motors and gearbox, this is produce high frequency pure tones. So they are more unpleasant because it's a broadband sound is, but if it is only tonal sound, everything is quiet and only one tone, pure tone comes. Actually, we have observed those who drive electric vehicles, you will find that they are actually more irritating. And after everything is becoming quiet, you have got a lot of other noises coming inside. AC compressor behind, it starts, it's cooling you, but that everything is quiet, so now it is irritating. Previously, there was a lot of masking because of diesel engine noise or gasoline noise, even cooling fan noise. Now it is irritating because everything is so quiet. Tire owners you're hearing, tire and jerks are you're feeling. Sometimes vacuum pump, as soon as you press the brake, vacuum pump starts, and intermittently sound comes. It's not good. So you have to work on every issue. So in fact, you'll find that EV challenges are much more than, in fact, somewhat more challenging. So this is a tonal sound you can see. And as I mentioned, the frequency range is very wide. So you have right from low frequency to high frequency. Everywhere the excitations are there, and you have to design the structural component. That means the modal element they call. The modal element, if you see for every component subsystem, it's very challenging in this case. And you have got emotions also. The racing cars now coming, they are electrified. And there's a famous YouTube, you can go through that. And you'll find that nowadays people, Ferrari and all that, they're developing special sound, artificial sound inside the electric car, so that they will feel like racing cars. So again, It's a big challenge how to make them sportive, or any car, even AC engine car. If you want to make them sportive, there is a separate theory and practices for that, and a separate research is required. And finally, lastly, autonomous driving of NVH. You'll observe that, as I mentioned to you, more exposure is there for NVH. So you have got optimized driving condition. And in that case, you'll observe that the attention to interior design, more compatible seating arrangement, and advanced NVH will be required. And that is why we'll find that first step of future technology, you need active noise cancellation, active sound design. It's not cancellation, but you design a sound in such a way that you like it very much, and integration of intermittent systems and enhance the audio quality, and also have vibration control systems. Sometimes active vibration design is also required. You feel some kind of that you should feel that the vehicle is running on the road. So sometimes you create artificially some vibrations in such a highly quiet vehicle, and people will not like it, especially on long drive. So all such future technology is very needed. Yes, that is why the conclusion is that vehicle image really matters more than ever in the present sense. Thank you. May God make the whole world quieter. Thank you.